Hi, in this video we're still looking at linear equations. In the last video we looked at gradients, but now we're going to look at the other part, which is the y-intercept. Now the y-intercept is basically where a line crosses the y-axis of a graph. So basically it's where it crosses the y-axis, so it means that when x equals 0. So in this case we've got our line here is crossing the y-axis at that point, so our y-intercept is at the point 0, 1. Let's have a look at another example. Here we've got an example of a line with a negative gradient, so it's going downhill from left to right. It's crossing the y-axis at -2, so my y-intercept is 0, -2. Look at the third example. Here I've got a line, it's given us 2 points of 2, 3 and 8, 6. But we need to look at where it crosses the y-axis. It crosses the y-axis at 2, so the point is 0, 2. So that's the y-intercept. Now that's nice and straightforward. Let's have a look at this example here where I've given you a table of values. Now this table of values, I'm going to ask you what is the y-intercept. Now remember, each one of these pairs is an x-coordinate and a y-coordinate. So that first one I could write as -1, 12. But I'm asked for where what the y-intercept is. Remember, the y-intercept occurs when x equals 0. So my y-intercept is 0, 8. That means on a graph, it would cross the axis at 8. This one we can see that as my x values increase, my y values decrease. So this one's going to have a negative slope. But the y-intercept is where it crosses the y-axis. So now I've given an example where I've just given you the equation and I'm asked you what is the y-intercept. Now I'm looking at this, I've got y equals 5x plus 7. Now remember, the y-intercept occurs when x equals 0. So let's see what happens if I substitute x equals 0 into the equation. I've got y equals 5 times 0 plus 7. 5 times 0 is 0, so I've got 0 plus 7. So y equals 7. So basically I can say when x equals 0, y equals 7. So this coordinate 0, 7 lies on the line, and that is my y-intercept. So now let's just have a look at what that was. That 7 is basically this number that's left here on its own. So y equals 5x plus 7. The 7 gives us the y-intercept. Okay, so we can say that the y-intercept occurs at 0, 7. So now we have another equation here, and I'm asking again, what is the y-intercept for this equation? So we said for the first one, the y-intercept is this value here. So it occurred at 0, 7. In our next equation, let's have a look. At first, people might say that the y-intercept is at 4, but let's see what happens when we substitute x equals 0. I'm going to go y equals 3 times 0 minus 4. 3 times 0 is 0. Take 4 gives us -4. So our y-intercept is 0, -4. So be very careful about this. Did you see that when I circled the y, when I was finding the y-intercept, I circled the plus sign with the 7? Remember, that sign is telling me what to do with the 4. It belongs to the 4. So my y-intercept is at -4. I'm going to look at another equation. This is another one that sometimes we see errors with, that people see this and they go, oh, the y-intercept is at 6, so it's going to be at 0, 6 is the y-intercept, because they see that 6 is the second number here. But not quite like that. We need to look at how these numbers work. So same again, I'm just going to prove it by substituting x equals 0. So I'm going to have y equals 5 plus 6 times 0, which gives us 5. So our y-intercept occurs at 0, 5. So remember, it's not what position and what order they're in. The y-intercept is the constant. It's the number that's not its own. Can you see that these ones, that's 5 times x, 3 times x, 6 times x. That 6 is multiplied by the x. It's the 5 that's on its own. So if I substituted 0 in for x, 6 times 0 is 0, and I'm left with the 5. So be very careful. You're looking for the value that's on its own. I'm going to do one more example. Now with this example, I did this just to check that people didn't get confused by where our positive and negative signs were. So if we look at this example, whoops, I've got 3 take 2x. So we can see that it's the 3 that's on its own. So our y-intercept occurs at 0, 3. Remember, this negative sign is telling us what happens to the 2x. Okay, so when we've got a term, the sign before it belongs to that term. So it's not negative 3, so it's 0, 3. We could check this by substituting x equals 0. So I've got 3 minus 2 times 0, which equals 3. So I'm just quickly going to go over these examples again. So my first equation, y equals 5x plus 7. I've got plus 7 is going to be my y-intercept, because when x is 0, I'm left with plus 7. So it's 0, 7 is my y-intercept. In my next one, I've got 3x minus 4. So when I have x equals 0, I'm left with take 4. So 0, negative 4 is my y-intercept. In this equation, I've got 5 plus 6x. When 6 times 0 is 0, I'm left with 5. So my y-intercept is 0, 5. And in my last example, I've got 3 take 2x. So I have got the 3 is left when I'm taking away 2 times 0. So when x is 0, my y-intercept is 3. So basically, when you have an equation and you've got it in the form of y equals mx plus c, that value that's on its own, be careful to take consideration of the sign, is your y-intercept. Thank you.